Hey, what's up guys, welcome back to another video. Today we're gonna see how we're gonna fix the STL files which we usually export from Rhino or Matrix, and how we actually union them. So here's a file I already imported, and in case you don't know how to import it, I'll show you again. So once you open your Magix, this is what you will see on your screen. So you click here for import parts, okay, or you can go on files and then you can click on import part. So once you do that, you open up any of the STL you have and then you click on open. Okay, so once you open, all right, in this case this is already fixed. So let me open something else. So I'll open up one more file here, and I hope this is not fixed. Yeah, for example, yeah, this one. So now I have two of them and I need to hide one of them. So what I will do is I will just click on this glass. So I want the other one to be hidden, so I'll just click on this one and I'll tick here. So this tick means we have selected the part which we want to fix. Okay, so once you have your file imported, you have to go in tools menu, you have to go in fixing menu, and then you click on fix wizard. So normally what happens in Magix 19, you can actually just follow these steps here with the follow advice and you can get it fixed. But let me explain you what really happens when you do a fixing. Okay, so if you see the files here, these are individual parts. So if I select any of this part, which there's no indication, but there's only a volume and a surface area. So once you click on it, you can see like which part you have selected, and for the camming purpose, for the 3D printing purpose, we have to union them just to make sure it's a watertight object. Okay, so here's what you do. Once you click on fix wizard, you click on follow advice, and then it should just give you a result like there is inverted, normal detected, and bad edges, contour, bad edges, whatever. You can see all these things report. The only thing we don't have to take care is these two things. Okay, so you just unmark them. You make sure these are unmarked, and the rest we just click on follow advice. Okay, and we click on follow advice again, unless you get shells. Now this is fixed, and I think this is also fixed. Now the only thing remaining is the shells. So the shells needs to be union. So what we can do here, we can either click on follow advice. So let me just go follow advice, and all right, so once you click on follow advice, you can actually come over here and you can click on unify. So once you unify the parts, and it takes times, sometime longer if there is some duplicate objects. So this is something you have to take care in your CAD file itself. You make sure you are not exporting a file twice, meaning the file has been copied twice on the same position and you're exporting as a whole design. So this is something you have to be careful when you do CAD designing. Okay, so here what I have done, I have merged all of these parts together into one part, so which is this one. Okay, so you select this and then you click on invert selection. This will select the rest of the parts which has no volume. So eventually we have only one part here, so you can either click on it or you can just click here and then you click on invert selection. This habit is good because sometimes you have list of parts where there's no volume, and invert selection is a very good choice. So you click on invert selection and you click on delete selected shells. All right, so this will be deleted. So next is to click on follow advice, and we can just check the report, like everything is green now, there's no red marks. So that means that this is good to go for 3D printing. Now there's something else I want to show you guys here. Is this is done now, and is that you see here the marks. These are the marks when you don't actually insert into each other the poly surface, and we have sometimes some marks over here like this. So how do you get rid of it? So this is what you have to do. You have to click on filter sharp triangles, and this is the normal parameters I use. It's 0.010 and the angle is 2, and you click on collapse, and you don't select any other things. Okay, so you click on OK, and this will just stitch those the gaps, if there's any gaps, or they will erase those marks for us. And as you can see, I didn't actually do much because eventually it wasn't really that close to get rid of it. Or I have to maybe change the value to angle 5, and I'll keep this as 20. That's right. Yeah, for some reason I changed it and I didn't change it back to the real value. So I hope this should be good now. Okay, it did, but at the same time there are some values, as you can see here, that it's not been fixed. Alright, so once you have this, you click on fix wizard again, and you go to shells, and now you can see you have list of 0 zeros here, which doesn't have any value. So you select the one which has a volume here, and you click on invert selection, and then you click on delete selected shells. Okay, so this way we'll be able to actually delete the shells which we really don't want. Okay, so this is done, this is fixed. Let me show you how you can actually see your parts in Slice. So if you want to check the slice, you can actually come up over here in Slice Preview, and once you click on it, you have to come over here, Slice menu, and then you have to input the value. Like for example, if you are working with a 3D printer which adds a slice, like a additive process. I mean, it's not a milling, but the adding layer by layer. And for some machine you have to do supporting on your own. So I'm not covering up the adding support menu here, but maybe I'll do another one which will be on how to make supports and why to actually make a supports. That would be something later on. We'll do this. So so if you want to really check the layers, this is what you have to do. You have to select the layers, the slice volume. For example, if you're printing it in a 50 micron, so the value goes 0.050. okay, and you just have to raise this up, and you can actually see your piece in slice mode. So for example, if you are printing this on a machine where you have to create a support, this would need a support here. This makes easier for us to see where exactly it's gonna hit the platform. So I'll make a complete video on this later on how to actually make a support and why, and that would be a good example. Okay, so but if you're working with a machine which does not require us to do a support, then you don't really have to worry about that. Just make sure your object is watertight. Okay, so here's the thing. As you can see now, they are connected. So for example, this was earlier a different part, but now you can see this, they are connected into each other. Okay, so here's the menu for checking your slice, you know. And in case you have to check some particular part, you have to just drag this, and you can examine where exactly. For example, now this is on a z-axis. We can do the same with the x-axis. Okay, so here I would go like hide section, and the steps is again how much microns. So for here I'll keep like 1.5, and shaded, and here active. Okay, so this is for the x, and this is only for examining purpose, you know, in case you have something to check. This is how you check it. Okay, now one more thing interesting is measurement. For example, you don't know how much is your thickness over here, so how are you gonna measure this? So this is what you have to do. You will find a measure page here. Okay, so I'll just bring this up here, and there's an option called points and points as well. So you just click on it, and you can see now this is around 1 millimeter. Okay, and then there is one more called thickness, one more command called thickness. So once you click on it, it does the actual calculation for you. It looks for the perpendicular position, and then it's gonna give you an exact thickness, you know, as if you are inserting a pin inside. So we have an exact measurement here. So for example, if you want to know how much is the height, you're gonna come up over here and you're gonna hit it in the center, nowhere else but only in the center. So this is 2.3 millimeter high. Okay, and if you want to know the height over here, you click here, and then you have the measurement. It's 2 millimeter almost. Okay, so this is quite handy, and it's very nice to. So I use these options. I use the point and I use the thickness. I don't really need anything else, so, and it makes life easier. So with the points, you just have to click on points. For example, if you want to know how much is the depth over here, so I'm going to click here and click here. So the depth is around 0.314. Okay, so that's how you check the measurement on your STL file. And this was the multi-section over here. You know, in case you want to know how is your Z doing, how is your X doing, and how is your Y doing, you can always, you know, hide away, or you can do a slice preview, a solid section, and this will help you with the checking, you know, checking the parts. Okay, hide away, or you can do a section only, and you can actually examine your file. Okay, so but these are all optional. This is only if you are having some trouble with your files, like if it's crashing and you really don't know why is it crashing and you're not happy with the result. This is how you're gonna examine that. Okay, so if you want to get rid of all these measurements, you just click on clear measurements, and boom, it's gone. Okay, so that was with the fixing. And once you are done with the fixing, I'll just uncheck this one, so I have my part ready here. I can either switch off to other parts. So for that, I just need to click on the glass here, and then tick here, and then click on the one which I was working on. So I'll switch off the one I was working, and I'll switch on to the other one. Okay, so let's just do the same process. Fixing, we click on the plus icon here, and we can click on update. As I said earlier, this is fixed already. There's nothing we have to work on here. So that's it. Now many people, they ask me like, do I have to make this bar here a support? Well, it's actually again depend which printer you have. For example, if you're having a SolidScape, I would suggest, you know, to have a thicker block here, a pipe which is thick, and it's much easier for handling them. Or in fact, you can even make a support with a hole on it. So what happens is, you don't really have to pick it with your fingers. You can actually use a hook, and you can just hook it onto the support, and you can pull it up. This way we are sure that we are not going to touch it with our finger, and because it's very fragile, we don't use it, we don't pick it up by hand. But if you keep on practicing and you know the right pressure to handle this wax, you won't do more damages to your printed pieces. Okay, so that's it for this one. Once you are done with this one, you just have to select all your files here. You just have to click it, and then you have to click on save part. This is the one. Or you can go on file and you can click on save part, which is over here. Okay, so just click on it and you select STL file over here, and then you click on apply to all, unless you don't want to rename them, and you click on save. Okay, so it says it's already exists. Do you want to replace it? I would say yes, replace, and that's it. We are done with this one. Okay, next, how do I reduce my mesh? So here's a good question. All right, this one. So let's take this one. This file, it's already reduced. As I can imagine, this file is done in JewelCAD, and this has been converted from SLC to STL, and that's why we have such a horrible result, because usually with Rhino Matrix you don't really have such a STL quality. So let me take some other file, because this is already so much damaged. I mean, not really damaged, but you can see the facets are so rough, they're not so smooth. So just unload them, you know, because we saved it, we don't want to save it again. So I'm just gonna press here unload. Okay, and then I'll open up some more files. Let's take a bunch of files. Alright, so this is something you need to understand. Whenever you have a small part, when you have something small, Magix is recommending us, like, if it's is it possible that this part is an inch part and you're working in mm, and you want to convert the part to millimeter, and we don't do anything else, we just press no, we don't do anything. Okay, just press no, and we know we are working in mm and we don't really want to convert them. Okay, all right, so I have lots of files here. To be very precise, it's 12 files here, and I would you know, there is two way you can actually actually organize these files with a distance, but depend again which machine you're working. So if you're working with SolidScape and if you have to arrange these files, this is what you have to do. You have to press Ctrl A, or let's say if you're working in any other machine, you just need to organize this. You have to press Ctrl A, and this command is automatic placement. So we just gonna keep like 1 mm a space between the between the parts, and then we click on OK. So it's gonna do the calculation for us, and it's gonna sort the files with equal distance, which in our case we had some parts here which looks all right. Okay, we have some files here which is very small. I don't know why, but they look like the same files to me. Alright, so if you want to get rid of some files, you just select them in a window and make sure this turns into green. Okay, so what really happens is that when you do a selection, you can see these are the random selections, and you can just get rid of it. So I've selected this one, and I would just click here, unload those parts. I don't want them, so just select and unload them, no to all. Okay, one over here, unload them, no to all. Okay, and one is over here. Okay, because there's a bit of confusion with these files, if it's really in or inch, but let's keep that for some other time. So this is how you organize your file. You press Ctrl A, and this will organize the files in with the equal gap. Okay, if in case you need to change some color, you can always pick the one you like, and you can see that it's changed into another color. Okay, alright, so what's next? This was just to how to organize them. You right click here, you select all, and then you can just unmark them. So in the yeah, just press no here, no to all. Okay, now this one I just imported to object, and in reality these are 6. As you can see, these are 1 2 3 4 5 6 sphere, and but they are grouped into 2. Okay, so 3 sphere together is one object, and 3 sphere together here is another object. So imagine you have such a file, and for some reason one is inserted into another, but in reality, if you see here, it's one file. So how do you remove one of these outside from this object? So this is what you have to do. You have to click on here, and then you click on shells to parts. Okay, when you do this, you know, it's divided into the parts it's made up of. For example, because this is 6 here, imagine if you have a ring which has thousands of prongs, and then you do this, and then you will have all of these parts listed down. Okay, but this is only possible if it's not yet Boolean together. Okay, so here's what you have to do. Once you do shells to parts, you can select one of these, and then you can just unload this one. Okay, for the moment I'm not going to do an unload. This is but just to show you how to get rid of a part from an existing part. Okay, so I would just say no to all, and for the moment I would just say cancel. All right, and how do I reunion them together? So this is what you have to do. You have to select this together. Okay, and you have to select this together, and you have to click on Invert Selection, and you hide them. Okay, hide unselected. Okay, so we have 3 of them, and now we come here, and then we use this option. It's called a Boolean Union, a unite one. Okay, so I have selected 3 of them together. I'm clicking on unite, so you press OK. At least one original part was not saved. You want to save them now, so it's completely your choice if you want to save any one of these. You know, I generally don't save them because I know what I'm doing, and I really don't need any copy of this. So I would say no, and that's it. This is united now. So this is Boolean, and this is all one piece. Okay, and okay, so just hide this one, and if you want to merge this together, you know, instead of unite, you just want to merge them together. This is what you just have to do. You have to click on merge selected parts. Okay, so there is a difference in unite, in Boolean, and merging. And what is the difference? Here I will show you. So if you see now this in a y-axis, okay, with the hide option, click here, you can actually see this one is one complete solid, and this one is still intersecting into each other. So that's the difference. Okay, this is what you have to make sure, like, you know what you're doing. So if you see now here, these three balls are still can be separated, but this one over here we cannot separate this. The reason is we did a Boolean union. Okay, we did a union on these three parts here, and that's the only reason we cannot union it. Okay, so you know, make sure you want to merge it or you want to unite it, so don't mix up the operation. Okay, all right, so this one for the moment I'm just gonna hide it, and I will convert this to parts again, and I'll show you some Boolean operation. Okay, a Boolean operation, if it has to be a separation one, then we have to select only two of them. You cannot do with the three of them. Okay, for example, here this option is not active because it goes only with intersection or unite, so cancel this one. And if I select two of them, now you can see this is highlighted. So as you can see with the color itself, if you want to subtract the green from red, you have to choose this one. Okay, and you can just check the colors you have here, or you can do vice versa. You can see the result itself here. So just make sure, keep it simple. You know, you want to cut a green one, cut green. This is the cut green, and this is cut red. So this is what cut red from the green. So you just press OK here. I usually do no, and that's it. And this was hidden, as you can see. This is back, and this is yet it's single part, so you can still unite this together. So unite this and you press OK. No. Okay, so that was Boolean operation. And the next is hollow it out, how you can hollow this out. So this is the option. The wall thickness is around 0.8, detail size is 0.1, and you want to hollow it out, hollow it inside. So that's why we have inside over here, and we press OK. That's it. This will just hollow the object from inside. And let's see in y-axis. Yep, as you can see, this is really nice command. You know, if you have some object where you want to just hollow the object, this is very handy. You don't really have to spend time in CAD and do a hollow operation. Okay, so that's it. And this way you can even save your resin. If, for example, if you're working in SolidScape, you know, in SolidScape what happens, there is two resin, two waxes. One is the pink and one is the blue. The blue is the actual casting wax. So you can use this technique only if you are well experienced in SolidScape. So don't try this hollowing out parts and you just keep it for printing. Maybe this will weaken up the file itself. Okay. But here I would suggest, once you do a Boolean operation or hollowing out something, I would recommend to fix it again. So just go here, go to shells, select the one which has the volume together, and also, for example, here there is minus and plus, so you select both of this, and then you click on Invert Selection, and then you click on Delete Selected Shells. Alright. So if you want to rename this file, because this is already renamed into hollow of bool 1 to whatever, and we just write what we want, hollow part 1, okay, and then you save the part. Okay, so that was how to make a hollow and how to do a fixing of a hollow one. Okay, now the only thing remaining over here on this one is how to actually reduce the triangle. So if I click over here, this is filter sharp triangles and this value has been fixed earlier, so we don't change anything on it, and I'll just press OK. And there was something, because this part is so tiny, we don't really see if there was any change on it, but we can always check the file size. Imagine if you have something bigger file and you do this triangle reduction, but don't change the value, as I said. Okay, don't change the value, and then it would be fine. Just keep this option. And okay, I think what did I do earlier? Okay, I think I did a sharp triangle, but this is the value. Okay, so click here, triangle reduction, and make sure you press OK. That's it. So you do more and more, and you get less mesh. Okay, and then you can just save this. So for example, this one is around 7.55 MB. Now just overwrite this one and we'll see how much is this now. So as you can see now, it's not even 1 MB, it's not even 200 KB. Okay, so the size is reduced a lot, and this will actually help you to to insert some more files, if you're printing on SolidScape. But you need to print and check the results with the eyeglass, if the final output is really smooth or we see some marks on it. Okay, so this has to be done with the visual observation when you have your piece ready. Okay guys, so I hope this video was helpful, and if you have any question, if you feel something is missing, do write me or email me or text me and I'll get back to you. Thank you very much, and you have a nice day. Bye bye.